Lumen point. Let's begin the breakdown.
AI, ML, DL, GenAI, if you feel like you're drowning in this alphabet soup of acronyms lately, you're definitely not alone. I mean, everyone is talking about them, but what do they actually mean? And more importantly, how do they all fit together? Well, in the next few minutes, we're going to unpack all of it. Let's dive in. So, this is the big question, right? These terms get tossed around all the time, sometimes like they're the same thing. But they're not. They are all connected, though, and honestly, the best way to think about it is like one of those Russian nesting dolls, where each concept fits neatly right inside the last one. So we're going to unpack them one by one, starting with the biggest doll of them all. In that biggest doll, the one that holds everything else inside it, that's artificial intelligence, AI. This is the big, grand idea, the entire universe we're going to be exploring today. At its heart, AI is really this huge, ambitious goal of getting a computer to simulate human intelligence. To learn, to figure things out, to reason. And believe it or not, this is not some new idea that just popped up. The concept has actually been around since the 1950s, way, way before it became a buzzword. It's the classic dream of intelligent machines. And for a long time, progress was, well, it was slow. Back in the 60s and 70s, it was mostly just a niche research project. Then, in the 80s and 90s, we got these things called expert systems. For decades, really, AI felt like it was always just around the corner. But then, around the 2010s, something fundamental changed, and things started to pick up speed. So how did we finally start making real progress? Well, that progress came from a major breakthrough in how we were trying to build AI. And this brings us to our first nested doll, a really powerful subset of AI called machine learning. Okay, and here's the real game changer. Instead of a human programmer sitting there trying to write explicit rules for every single possible outcome, which is impossible, machine learning lets the machine learn for itself. You just feed it massive, and I mean massive amounts of data, and it starts to spot the patterns and make predictions all on its own. It's a powerful method for achieving that bigger goal of AI. To really get a feel for this, let's try a quick little example. I'm going to show you a simple pattern, and I just want you to predict what comes next. You ready? Okay, so you see a square. Then a circle, then another square. What's next? You probably said circle. Easy, right? Based on just a little bit of training data, your brain learned the pattern. A machine learning model does the exact same thing, just on a mind-bogglingly massive scale. But what if the pattern breaks? What if we have square, circle, and then suddenly a triangle? Whoa, something's different. That triangle, that's an outlier. And spotting the things that don't fit the pattern, that is another one of machine learning's key strengths. And that right there, that simple example shows you two of ML's superpowers, making predictions based on patterns and spotting outliers. This is incredibly useful in the real world. I mean, think about cybersecurity. An ML model can learn what normal, everyday traffic on a network looks like, and then bam, it can instantly flag a potential intruder. It spots the triangle that breaks the pattern. Okay, so we've got AI as the big universe and machine learning as a huge galaxy inside it. Now we're going to zoom in even further to a specific star system inside ML. This is deep learning. Deep learning is a more advanced, really specialized kind of machine learning. It uses these things called neural networks that have many, many layers, and that's actually where the deep part of the name comes from. The whole structure is inspired by the web of interconnected neurons in our own brains, which lets it learn much more abstract and complicated patterns than traditional ML ever could. And this is where it gets really wild. A lot like our own brains, these deep neural networks can sometimes be a bit of a black box. Because there are just so many layers and it's so incredibly complex, we can get a brilliant, accurate answer without being able to fully trace back exactly how the model came to that specific conclusion. And that brings us to the very smallest doll, the core of all the recent excitement and buzz. This is the piece of the puzzle that put AI in everyone's hands and totally changed the game: generative AI. So generative AI, or GenAI, is this revolutionary leap forward. While older AI was mostly about predicting things or classifying stuff, GenAI, just like the name says, creates. It's a type of AI usually built on those deep learning networks that is specifically designed to generate brand new content. We're talking text, images, code, you name it. And it's all powered by these massive models called foundation models. So let's take the most famous example right now, large language models, LLMs, the engines behind chatbots. How do they work? Well, just think of it like the autocomplete feature on your phone, but on a massive dose of steroids. They basically read a huge chunk of the internet, learn all the statistical patterns and relationships between all the words, and then they get insanely good at just predicting what word should probably come next. Now, you'll hear people argue that GenAI isn't really creative, that it's just spitting back things it's already seen. But think about it this way. When a musician composes a brand new song, are they just regurgitating old notes? Of course not. They're using the same existing building blocks, the notes, to create something totally new. And that is a fantastic way to think about how generative AI works. And it is so much more than just text. This is the technology behind the chatbots you talk to for customer service, the AI models that can clone your voice from just a short audio clip, and even the video models that can create stunning and, yeah, sometimes pretty worrying visuals. This is a technology with absolutely incredible creative potential. So we've unpacked all the layers. We started with the big universe of AI, then ML inside of that, DL inside that, and finally GenAI right at the core. And this whole nested structure, this is what explains why it feels like AI just suddenly exploded onto the scene out of nowhere. For decades, AI adoption was slow and steady, just kind of creeping along. Then machine learning and deep learning came on the scene, and we saw a definite uptick. But when generative AI and those foundation models arrived, adoption didn't just grow, it went straight to the moon. So here's the absolute crucial point. This final, innermost layer, generative AI, is what made this technology accessible and genuinely useful to millions of people, seemingly overnight. It fundamentally changed the game, and it's the reason AI is now being adopted just about everywhere. So there you have it, 4 distinct but deeply connected concepts. It all starts with the big dream of artificial intelligence. That dream started to become reality through machine learning. A really powerful way to do ML is with deep learning. And the latest, most explosive application of all this is generative AI. So now you know the difference. You know the what. But honestly, understanding what these things are is just the beginning. The real question is, what comes next? As these tools get better and better at generating not just new content, but new ideas, new solutions, maybe even new realities, what does that future look like for all of us? That's the question we're all facing now.
Fuel your curiosity. Subscribe for the explanation. Stay for the knowledge.